So for example, let's say Z, which is equal to proton number or the atomic number. Let's say Z equals 10. So that means that's the proton number, and since it's an atom, the number of protons equal the number of electrons. So the electron configuration will be 1s2, because there's 2 electrons, 2s2, 2p6, that gives us 10. So that would be the electron configuration for this atom. So the 1 symbolises the actual energy level, so 1 would be the n equals 1, n equals 2. And since n equals 2, and at the second energy level there's s and p orbitals, that means, well, there's going to be s and p orbitals in the second energy level. So then, since the s orbital can hold, since one orbital can hold up to 2 electrons, then the s orbital, which is a single, is one orbital, will be able to hold 2 electrons. And then the 2s orbital is going to be able to hold 2 electrons, and then finally the 2p orbital. The 2p orbitals will be able to hold up to 6 electrons, because while there's 3p orbitals, and since there's 3 different p orbitals, then 3 times 2 is 6, so up to 6 electrons. However, it gets more complicated, as if we have, for example, an atomic number, a proton number that is, let's say, 20. Let's just double it. It's going to become 1s2, 2s2, 2p6, 3s2, 3p. How many do we have here? So that's 4, 10, 10, 12. 12, so we need 8 more, so we're going to have 6 here. So that's 10, 12, 18, so we need 2 more. So since the 4s energy level is at a lower energy than the 3d, the 4s is going to be filled first, so it's going to become 4s2, and that makes up 20. Is equal to 20 electrons if you count them up. So that's 4, 10, 12, 18, 20. However, if we had, for example, 23 electrons, then it'll become 3p6, 4s2, and then 3d. 3d, that's what? That's 4, 10, 12, 18, 20, 20. We're going to have 3 d3 electrons. Right, okay. However, as with everything, there are exceptions. These being chromium and copper, which I can explain, but I mean, it's easier if you just look at the actual, if you research it. Okay. Okay, that was it for now. Thank you.